Good afternoon. We're going to get this started. So first today, we're going to have a couple of items I want to get through. First, we'll start with introductions with Mark, David, and myself. And then we're going to talk a little bit about our partnership, why we're here. And then from there, it's going to be some slides from myself, just talking generally about the impacts of AI, but also Black Duck Signal, right? The title of this talk with Language-Agnostic AST, or SAST. And then I'm going to mention about context AI, but just before we kick off, a little bit about myself. So Christopher Fearon, I work in Black Duck, and I have done for a little over 10 years now, most predominantly in the research space for SCA, vulnerability research, vulnerability detection, and recently I've been involved in more research around our entire portfolio. And of course with AI today and the possibilities with AI, I've been heavily involved in AI research in our products and our portfolio. And like I say, my focus has mainly been on the SCA side of the house, but also diving into static analysis as well. Mark, David?
Yeah, so my name is Mark David McLaughlin. I know a number of you, but I'm responsible for the security architecture and engineering organization at InterSystems. And part of that, the fun part, is working with partners. I know we've been working with Black Duck for a number of years, bringing the customer concerns about how do we provide better security assurances around ObjectScript. About a year and a half ago at a security conference, we were having a discussion, and the Black Duck team came to me and said, hey, we finally have something that we think is going to really fit your customers and you guys with scanning ObjectScript. And so we've been working on this probably since almost over a year now. Yep. And it's to a point where I don't want to take too much away from Chris, but it's generally available, and I thought it would be great to kind of present the journey and the technology to all of you. So with that, I'm excited that you're here, and thank you.
Yeah, thank you very much, and thanks for inviting me.
Yeah.
It's great to speak to this topic. But just before you leave us here, can you give everyone a sense of the teams that you're responsible for and really the scale of the security problem that you face?
Yeah, so, I'm responsible for the security posture of all our products and somewhat cloud services. So all the code that goes in, all the infrastructure is code that really set the requirements. And then Anthony and his team, actually own the infrastructure where Black Duck runs. And it affects the entire development organization, as well as our compliance organizations who use the reports and provide information to our customers. So.
And what impacts have you seen from AI in general in the space? How's that made your life harder?
A lot. I think we've heard today InterSystems has really embraced AI. Terry at the beginning said, shortly after ChatGPT was announced as a company, we've looked to innovate with AI. And what we've actually done is we view it as an opportunity to fulfill all the other projects that we didn't have time for. So really, we always had more areas where we wanted to invest and not enough resources. So we're leveraging AI to invest in those areas. And I think this is a good example of where some of that innovation comes in.
Perfect. And last question from me, not to put you on the spot, of course, but has there been anything that surprised you? We've been working for some time with Signal that we're going to talk about today, but has there been anything that has surprised you, positive or negative?
No, I think, everyone comes into things, I think, with a little bit elevated expectations, and then you kind of work through the issues, and then you get to a steady state. And I would say that working with you and your team has been very good in, we've tested it on a number of different ObjectScript repositories within InterSystems. And at first we had some challenges with the size of this data that we're analyzing. And we're still working through the validation of all the issues, but I think as any technology, it shows a lot of promise. So,
all right. Thank you very much.
Yeah, you bet. Enjoy.
Thank you. Okay, so a little bit about AI and the ecosystem that we have seen. So we have our traditional developer workflow that has been tried and tested and worked for years. But with agentic development and agentic capabilities, we have seen that totally disrupts that existing workflow that we're all used to. There's an element of letting go with some of this and having the trust in the models as well. And essentially, we're seeing just a total disruption in the space that we are comfortable with and what we are used to. And we can see here with Gartner's statement, essentially by 2028, virtually everybody will be using agents in their coding assistants. Now, I find this quite amusing, all right? Typically before we would do some coding, especially for people like me, that probably shouldn't be letting near code anymore. But you do some coding and then you do some debugging and you sort it out. But what we're finding now, the reality of using these coding agents, we can do so much so quickly. We code for 5 minutes, but you end up debugging for 24 hours, right? Just because there's a number of factors that we'll go over. Poor prompts leading to poor code. It's very hard to be on track with your discipline when you're coding with these agents. It's far too easy, and myself included, I find myself, wow, this is amazing. You've got that full sense. You can do so quickly. You can do so much so quickly. But the problem is the prompts. If you are not disciplined with them and you have a routine you follow, it is quickly going to descend into madness, essentially. And another area here is how to ensure that all your developers are using the same depth of prompts and guardrails. It's challenging to keep on top of that. Hallucinations and logic errors. What you think you're asking the AI to do versus what it's actually doing is another challenge. On the surface, it may report that it has done something, but can you validate it? Have the tests have you written? Have they been developed by the AI who believes it has done the correct thing? Is it returning you what you want to hear? And some of the gains you can get really quickly are in real complicated business logic, where the AI or the model doesn't necessarily have the context that you have about the code base that you assume the model has context. So that can be a challenge. Code bloat and complexity. When I review some of the code that's produced, it's produced 100 lines of code, which could be done in 10 lines of code, right? It overcomplicates the issue just to try to be smarter. And of course, then that leads to complex issues arising that are hard to review. Familiarity with the code. As we're starting to see, there's this desire to develop quicker because we have these agents. And with that, we have seasoned developers where there's more workload being put on them to actually produce more features and move faster and quicker. But the problem with that is you lose familiarity with the code base itself and what you're actually writing. If you're spread too thin, that can be a challenge. Developer skill atrophy, right? I mean, if you are continuously, if you don't use it, you lose it, right? So if you're migrating a lot of your workload to the agents, it can be quite quick to lose some of that sharpness and some of that edge. And then, of course, you're relying on code reviews and reviewing the work of the agents. But of course, the problem then, we're shifting the problem. I don't know if many of you experienced this, but you can write the features so quick, but the backlog is now switched to the code review side of the house. So with those observations, we worked on a product called Black Duck Signal. And it's essentially our agentic approach to application security testing with the amount of code that is being generated. Now with that, yes, it does use LLMs, use multiple of them, but it uses various different agents and workflows to analyze your software. It is language agnostic. That's one of the key points here. It does not rely on pre-built rule sets, such as the traditional static analysis tools out there today, even ones that we produced, Fearon, Sigma. They require a non-trivial amount of research and development in order to support languages, and they run on rules essentially. And what the LLMs and the AI space allows us to do is to actually leverage the capabilities we have with those tools, but we're not bound by the limits of the rule-based process. And of course, that allows us to work on proprietary languages like ObjectScript. It also interacts with developers and agents in natural language, right? We have multiple different delivery methods for this, one of which can be native to the user's development environments, but it can also be in a CLI tool that you can use in your workflows. We also perform cross-file data flow, and that's a huge benefit, especially when we talk about the language-agnostic behaviors. So what we've been able to do is leverage the in-house experience and skill sets through the Fearon and Sigma work that we do, and understand how can we orchestrate a series of agents in a way that we normally would with traditional SAST. And cross-file data flow analysis, it allows us to really validate some of the findings that we're actually surfacing. Okay, it's one thing just asking an LLM, find me an issue in this file. It's another thing to have those processes backed by the years of knowledge, that we've baked into the system to understand the nature of cross-file data flow and trying to determine if an issue on the surface is really an issue, or it's actually a false positive, or it should be less severe or more severe. And one of the benefits that the LLM technologies and AI in general gives us is the fact that we can perform human-like analysis, right? The LLM can actually look at a piece of code and actually use its reasoning capabilities to understand the context, understand the intent, and that is something that the rule-based engines can't do. So, some hurdles with traditional SAST, and I've touched on some of them already. First, we need to parse a particular language into a call graph or an abstract syntax tree. And from that, we're able to then define the data flow features, which is essentially the architecture, the capabilities of the component or framework or platform that we're actually analyzing. Ultimately, we want to determine where the sources are of data, the sinks of that data, the pass-through, meaning which functions or methods or capabilities in the framework or language where the code actually traverses to get to from the source to the sink. And the sanitizers, that's very important from a security perspective, right? What's inbuilt in the framework and the language itself. And of course, we then write the rules on top of these items that we label and we find. And for call sites and data flow traces, which are encapsulated by the source, sink, pass-through, sanitizers. And what we try to do then is build the rules on those models that we build for static analysis. And of course, we can only write rules for what we find and what we see. And that's where a lot of the time and research is involved. So if we want to support a particular language in static analysis, we need to have a capability to build the models so that our tools are able to identify them and then be able to write rules or security rules, quality rules on top of those labeled data points to actually find security issues. And like I mentioned before, that is non-trivial work. That takes expertise, research, from both engineering and security analysis. And then there's a lot of testing. We need to also look at the false positive rates. There's a lot of work that goes there to make sure that we're not producing too much noise. So that all can be quite complex and time consuming. And if we see here, this was from a Stack Overflow study a few years ago. But you see just the sheer volume of packages and frameworks that actually exist. And this is just for one example on the Python forge, PyPy. If we are going to support in traditional SAST, Python, for example, what versions of Python do we support? And then what frameworks that are built on Python do we need to support? And what libraries? We need to perform that modeling for every single language, because they bring, version of that language, because they may bring new capabilities. So that amount of work is non-trivial, like I said. And some additional pieces where AI and LLMs actually really help fill a gap, right? Understanding context. A rules-based engine doesn't have context. It's binary, it's 1 or 0. Detecting logic issues. These type of issues, as I said, because you have context, it can find novel items that traditional static analysis just can't do it, right? And some of these logic issues I'll go into, and they can also be combined together to find more compelling items that you wouldn't traditionally find with static analysis. Blacklisting bad coding patterns. So, again, non-trivial amount of research that goes into actually building security rules, quality rule sets. But bad coding patterns, there's a lot of them, right? So it takes time, and all the implications go into that in terms of the performance of the scan. We need to take that into consideration. It's a balance between false positive, true positive, and it's a consistent battle between those. So, a lot of people will ask, well, I mean, how does this work, Chris, right? I mean, is this just you're pointing it at a LLM and asking it to find security issues? I wish it were that simple, but it's not now. You can do that, but your mileage may vary. We use multiple agents along the process, which we'll dive into later, but programmatically we create focused tasks based on our initial findings. We have multiple layers of validation and oversight, so we know that LLMs are non-deterministic, right? But we've been working to actually put them to a position to be more deterministic within our harness, if you will, within our framework. And we know that's important, especially for enterprises and customers that want to have consistency between scans, right? If they want to know if they're improving their security, if it's getting better, if it's getting worse, or what's happening. So we understand that there is a need for that level of consistency. And we have achieved that consistency with traditional static analysis. We know how to do that, but it's a different process with LLM and non-deterministic engines. And this final point is really important, right? We're able to tune the agents in a way to allow us to leverage that reasoning capabilities that comes with it, right? We take all the knowledge and context we know of how to perform static analysis and programmatic analysis, and then we sort of apply the strengths of the LLM, right? We want to understand, it's like a rubber duck review process, right? You have this LLM that's able to review it with a context, with all the other information that we're able to gather, and then actually perform essentially a code review. Right, and that's how we try to bring the capabilities of that and the strengths of a model with the human code review level and bring that into the scan itself. And is this thing real, right? We have found multiple 0 days using this process, and I know everyone has heard and read about Mythos and Anthropic and the work they're doing, but we have found in a similar story, in a similar vein, lots of 0 days and popular components that are out there. Some have been silently patched. Some of them are currently in responsible disclosure. Some of them have CVEs themselves already. But it goes to show that these are tools or libraries or frameworks that have been scanned for years with traditional technology, and we haven't found these issues. And having this reasoning-like capability, along with the other advantages I've mentioned, we're able to find these new novel items. And like I say, we have pending 0 days, and these are not homework projects on GitHub that we're scanning. These are really popular, well-used components, various different languages, and we have items that are pending disclosure. Anybody, any observations about that? Anybody recognize that code? Any takers? Injection's the problem, but the code itself, it's actually just pseudocode. This language doesn't exist. But the purpose of this slide is to show when we were running tests on this, we were able to successfully identify the intent behind it. There was injection in the SQL statement. So traditional SAST wouldn't be able to capture this, right? Because they haven't modeled pseudocode. But the point behind this exercise was to understand, could we even investigate proprietary code of which the LLM's not even trained on? It will test the reasoning capabilities of the model, and can it identify those patterns that we should be concerned about? And here I'm happy to say that we did find the SQL injection, but also able to recommend the fix in pseudocode, right? So that was pretty impressive. But beyond standard software vulnerabilities, we wanted to test this process on malicious code detection, right? Not inherently vulnerabilities. but malicious code, right? And we're actually seeing, part of my role, I oversee a team of vulnerability analysts and researchers, and we are observing the sheer amount of new vulnerabilities coming through the system through MITRE. We seen recently that NVD put the white flag up, essentially acknowledging the sheer volume of vulnerabilities that require analysis. And we see here, this isn't slowing down. The attackers have access to this technology as well, and we're seeing the supply chain is absolutely inundated with malware, and it's a rich threat landscape, essentially, right? I mean, we always knew the supply chain was challenging and at risk, but now even more so. So the NX Singularity hack, this was actually one in the supply chain and NPM, I believe it was, where we actually seen the malware try to leverage the coding agents that were installed on a user's machine. So we have here a prompt in the payload where it was actually invoked whether we're using Codex, Claude, etc. And it was actually hunting for secrets and keys on the user's machine on behalf of the attackers. And essentially then it was, exfiltrating the data out. So there's nothing here inherently that's a vulnerability, right? I mean, the code's doing what it's supposed to do. There isn't a vulnerability. But what we were able to detect, first and foremost, as part of the payload, that we have this suspicious shutdown command. So essentially what we had was every time the user tried to open a shell, it would just shut it down, right? Just try to slow them down, to slow the defenders down. Then what we were able to highlight here was this upload, right? Upload payload. So upload the token. Suspicious in nature, again, not inherently a vulnerability. And then we actually seen the source, how the attackers got into this particular repo. This was actually an insecure workflow file in the CI system, right? So they were able to leverage that. But the point I'm trying to get across here is these are 3 items which aren't inherently security vulnerabilities. And using in the reasoning capabilities, we're able to detect all 3 of these items as being potentially suspicious. And that leads us to a point where we can actually chain these items together, right? If we look at the likes of the MITRE attack framework, we can align these items to categories in MITRE attack. And then you start to see you can build a picture. So the capabilities used correctly, we can identify more novel items than just typical security vulnerabilities. Here's another one, NPM. This one was actually hijacking for crypto wallets. Again, the same thing, not inherently vulnerable, but we're seeing this suspicious obfuscated code use. And that's been highlighted, right? Because heavy use of obfuscation, there's a reason why it's been obfuscated. You should check it out. So essentially, with Black Duck Signal, works natively with your coding assistants. So whether you're in VS Code, your cursor, etc., you can use it with natural language. You can also use it to find defects in real time from a developer perspective. Language agnostic, as I've mentioned. And it may sound like I've been very negative towards SAST, but the reality is it complements traditional SAST. There will always be a need for that deterministic result. But what we see with Black Duck Signal, that it fills a gap the traditional static analysis can't. But we can also use this technology to reduce the noise of application security testing in general, right? So we have these items that are flagged from our rule-based engines, but we can leverage the agents that we have in Signal to actually overview, right? Actually provide oversight and review with the additional level of reasoning and really focus in on items and understand if these things are true positives. So it's not just, we understand in today's world, finding vulnerabilities, finding issues is becoming easier. The barrier has been lowered. But the problem now shifts, okay, how do we fix them, right? We have more issues now to deal with. We couldn't deal with the issues we had previously. So we're looking to leverage how do we actually tune out some of the noise and get to the signal. Here's some the models themselves, we use a combination of models, but it is likely that the models have also been trained on these data sets as well, so it's sort of fitting the model. But what we find against other solutions, that we're actually finding more true positives and less false positives. Okay. Now, part of our analysis here, we were able to remove any of the labeled information in the data sets just to make sure that the model didn't have visibility to that. But again, what we find was really compelling across languages that traditional SAST doesn't support, and also languages that they do support, we were finding more true positives and less false positives. And again, I want to get back to the point that Signal and LLM agentic security analysis, it complements and enhances traditional AST. We have the benefits here, right? The deterministic results support the consistent triage, like I was saying, that people want that consistency. But Signal and this new technology can help us identify those items or blind spots, or in languages that just aren't traditionally covered. High-level architecture, so you can see here, we can be used in various different capacities, right? We can be used in the IDE and the native code agents. We can use it in the front end, web. We can use it in the CLI. We can use it in your CI environment. And essentially what Black Duck Signal is a series of agents. And today we use our own models, which are hosted in our infrastructure, but we're going to move to a model to bring your own model. So you can keep it in-house if you wish. But one of the items I want to highlight here is context AI in the bottom right. So anybody can build a series of agents that work with a code base. But what we want to bring to the table is essentially the years of experience in Black Duck from the open source industry, from our static analysis, from our BSIM practices, and the coding standards that we have knowledge of. And we want to sort of bring that and essentially help steer Signal with this additional context, right? We think that will be really important to actually provide additional value on top of a single, are there any vulnerabilities in my code base? We want to bring that years of knowledge and expertise into the scan itself. And really, what does that look like? So, as I said, our OSS components, we want to also implement the other technologies that we have, right? It won't be true that LLMs are the tool to use for every scenario, but they can certainly orchestrate them. Our M&A audits, so we perform Black Duck's security audits. We have them for years alongside our typical product offerings. And we're able to bring all that context into these scans. We want to make these scans more intelligent rather than just leaving the AI up to itself. So there's a couple of items I want to discuss about research with this technology in general. The Black Duck knowledge base integration, this is actually something that should be pretty obvious to anybody that uses Black Duck, right? We have years of experience with vulnerabilities, with license data, with open source software components in general. And we're working to actively integrate our scanning capabilities with Black Duck, right? To understand the metadata behind the versions of the components we're scanning. Like I say, the other data such as license, vulnerability, and understanding end of life data. That's always been an important one. A lot of our customers have also asked us, can you tell us when a component is end of life, right? Because we need to take that into consideration. Leveraging our Open Hub data, the metadata we have amongst these components, we want to be able to provide that context into Signal. And that will really empower also decisions of what's my upgrade path, right? Especially if end of life, right? You want to get off that totally and get onto something that is stable and is actively developed. So we're hoping that will bring more context. And we see if you've used AI, it is really bad at bringing in old components or components that just don't exist, right? That's a supply chain issue in itself. So, when we're working with these coding agents and we're building new features and we, expectedly bring in new requirements, how do we know those requirements are sound requirements to bring in, right? We don't want to wait until we run a scan on our CI to find out that we're using an out-of-date component with 100 vulnerabilities. So we want to bring that context to the developers at the time that we're actually performing this analysis to steer them in the right direction. Threat modeling and risk-based scanning. One thing that we have observed is, yes, there is an explosion in code generation so far, right? We've seen there's never been so much code produced thanks to the AI agents. And even with traditional tools, it is challenging to scan these, right, at scale all the time, right? And we now have to become more selective as what we're going to scan, what our scan cadence is, and we need to be smarter. It's becoming a challenge with the traditional technologies to keep up with the rate of new code that's being generated. So we're working on the premise that we need to be smarter with what we are scanning and when. So essentially what our threat modeling allows us to do with Signal is perform a threat analysis, or in fact, provide your own that has been performed externally, but then use Signal to orchestrate what tool to use in what scenario. So our threat reports will say, you have a weakness in this area of your application, you should use this tool. So it'll be a combination of orchestrating our existing tools where it makes sense, but perhaps using the Black Duck Signal brand. User supplied context, that's a big one. So we have a scenario where it would be great where we have a proprietary language, say ObjectScript, where we might actually get more, we might get better results if we're able to provide the system with context about that language, right? In our testing, we find that yes, we are finding items. However, there's a nuance to this particular language, or there's there's some semantics that make a difference in this language. Having that information available to the model during the analysis, during our oversight, can be really critical in pruning out some of those false positives. And we actually think, it would be able to steer these models in the right location and keep it on point. And it'll actually reduce some of the hallucinations as well. So we actually think the user supplied context given the scan target is going to be something that's really powerful and can be leveraged in different scenarios. There could be different context based on the application under test. So that's why it can be dynamic and can be really powerful. Semantic code graph. So, we know that using LLMs at scale like this isn't cheap, right? There is a cost to it. So what we want to look at is understanding how can we leverage semantic graphs. And I kind of like, this is similar or akin to ASTs and traditional static analysis. As I mentioned, we build ASTs and then we label the data and then we build rule sets on top of them. And the way, agentic AI works today, we have a series of tools that are associated with the agents that can perform duties orchestrated by the AI agents. What we actually do is leverage some of the capabilities and expertise we've learned with the traditional world of static analysis and bring those concepts into the agentic analysis. So semantic code graphs allows us to label security data, label that context that we want to provide the system, and let the agents have access to that code graph to make smarter choices. And that will help define and identify the sources, the pass-throughs, the sinks more accurately and more cost-effective. Verified autofix with regression testing. So, as I mentioned earlier, it's one thing to be able to find new items, right? It's now easy to find items. But the real question is, okay, so you're smart enough to find a bunch of issues, can't you just fix them for me? Like, why are you leaving it? Why are you leaving it to me to fix? So the verified fix, what we're attempting to do here is to obviously, based on the findings that we have and the context we have, just to go ahead and fix the items, right? And then perform some of the testing and validate that our fixes don't actually result in more issues. And then exploit verification. So this is a big one for prioritization. We've heard, whether it's an SCA or a SAST, can you prove reachability, right? Well, not every vulnerability needs fixed, right? But we need a way to prioritize these items. But what, again, this technology allows us to do, we can actually perform testing on containerized sandbox environments where we're actually building the exploits, we're running them, and we're actually testing if a particular vulnerability is reachable and exploitable. Reachable and exploitable are two different things, but to exploit it first must be reachable. But having this level of capability allows us to validate that these are your priority items to fix. It's a level of prioritization. But what it can do is also provide the logs and information back to the security team, right? If I bring it back to my statements at the beginning where I mentioned that familiarity with the code base, we're losing that the more as we use coding agents. But if we're able to provide this level of feedback back to the security team and then back into the development teams, then we can expedite the process of actually reviewing and hardening that particular code. We use multiple LLMs, so the agents themselves, each agent uses its own specified LLM based on the job at hand, right? We're not just using one single LLM for everything. But we also have the capability to do disagreement resolution, right? So we want to make sure that, if 2 out of 3 LLMs actually confirm this, then there's a high confidence that this is actually accurate, right? So this goes to how we have multiple levels of validation and oversight. This is something else that we're wanting to roll in with a disagreement resolution. Continuous learning system. So what we're conscious of as well, we don't want to make the same mistakes and keep reporting the same types of issues over and over again. So if there are items that have been triaged or marked as acceptable, et cetera, we want to be able to feed that back into the system. And that can really just help, well, a number of reasons, reduce the cost, reduce the noise, but it also is involved in the bigger ecosystem that we have in Black Duck. So we want you to be able to pull down your policy information from the other tools you use in Black Duck and actually apply those to the scan results. And we want to also bring in the results from the other tools, right, and be able to inform the agentic system to use this metadata as context. So we're continuously learning about the applications under test, what other tools have found about this application, and more context is better for these types of systems and keeps them on point. So with that, we have a lot of items that we're working on, but I'm really encouraged and super, I'm really excited, and I'm looking forward to what we can do with this technology. Right, it really fills a gap from what traditional tools can find, but they're complementary with the existing tools. So there's lots to explore here. That's me. Thank you very much. Thank you. Anybody have any questions? Yeah, so just to repeat the question for everybody, it's where do you see this type of tool being deployed in the user workflow, shift left, or in a more CI/CD type setup, essentially? It can be used anywhere, but what's going to play into that equation is cost and time of scan, right? I actually think this type of technology, because we have that reasoning capability that's more akin to a human assessor looking over it. I think this technology is best suited where you're doing a point-in-time scan on a major milestone in your CI/CD. We do have capabilities with Signal for a developer to use it in the IDE, where we perform essentially scans on diff patches of what the user's producing. But the problem there is you don't really want your developers burning up tokens on small errors, right? So to really get the power of this system, you want to be using it at milestone scans in your CI/CD. Yep.
Aside from any extra work, do you think there is effectiveness of being applied to dynamic analysis too?
So just to repeat the question, can this be applied to dynamic analysis? Yeah, so it's something we are working on and exploring. We have capabilities today on Black Duck to perform dynamic analysis. There will be elements of these agents that can perform dynamic-like assessments. Again, it's going to come back to your appetite for cost and running this thing. But yes, we can do that.
What do you see as like the Software trials that cost, like in terms of time, how long it takes to run on, say, 100,000, say like 1,000 files?
I love that. It's a loaded question. Performance-wise, how long does this take over 1,000 files, right? Honestly, it's not a cop-out answer, but it entirely depends on the density of those files, what the language is, how complex the code is. Because we perform the cross-flow data file now, so essentially what you're looking to do is, you find the initial seed of a vulnerability per file, and if we believe that it requires data flow, then the data flow agents take over and do the necessary turns to find the issues. We do limit that. We have ways to limit how long those type of analysis goes on for. But the expectation should be this. I mean, this does take longer than a traditional static analysis scan, right? But that's because we're doing a lot more, right? But yes, it's not something aside from the developer use case where we have ways to analyze, patches. If you're using this in the CI/CD, you might want to make yourself a cup of tea and then come back. All right. Oh, one more. Do we run into any issues with the LLM giving us refusals? So I guess you're assuming like 429, too many requests, things like that, or?
More so like, sorry, I can't do security research.
Yeah, so it's funny, we haven't. Now we have when we've been doing some of our internal testing on certain areas, but a lot of that is based on your system prompts and how you are setting up the LLM to do certain activities. There are certain scenarios where we've run into in our exploit verification, say, when we're actively trying to exploit something. That's where we do see a wee bit of hold on a second, roll that back. But in general, when you're coming from a defensive standpoint, we haven't had that problem. Thanks, folks. We have a stand out there if you have any other questions, but thank you for listening. Okay.